Okay, let's have a go at a standard textbook type question. So, like with the binomial distribution, you always have to say what x is. So, x in this case, x is and the only word you have to change is this next word. So what are we doing here? It's the age of a randomly selected. What is it with the selecting? It's students. So when defining your x, it's easy on this one. X is the age, height, length of a randomly selected student, fish, cow, whatever, apple. Then you need to show the distribution. You say that x is distributed normally, and you have to quote mean and standard deviation, mean and variance. So the mean, the population mean is 24.5. The variance is 2.5 squared. Now, let me just undo that. Put this in red. Look at that. The most common mistake is not quoting the variance when you quote your model. Many people quote the standard deviation when they quote their model, and the reason you're getting this in this way wrong is because on the calculator, you don't enter the variance, you enter the standard deviation. And that leads to a lot of confusion very commonly. Students never seem to get over that. So you have to quote the variance and the population mean. So then, for A, we want to calculate the probability that a student is younger than 26 years old. What I would recommend for all questions, these ones are quite easy, you don't need to do it, we'll do it for these ones until you get used to it. I want to always sketch the normal distribution curve and shade the area you're looking for. This will give you a method point. But if we get in the habit of doing this always, it will help when we get to harder questions later. There are harder questions for this, but if we go through the basics many times, you'll find those ones easier later. So here we've got the age. We have our normal distribution curve. Here is the mean. What is the value of the mean?
24.5.
Population mean is 24.5. Standard deviation is 2.5. We are after 26. Is that higher or lower than the mean?
Higher.
It's higher than the mean. We are after this point here at 26. Do we want to shade the left curve or the right tail? The left tail or the right tail?
Left.
We want a student that is younger. We want the left tail. So it's this tail identification, which is what you sort of get your credit for. And having this will help you with problem solving sometimes. Knowing that it's going to be more, what we can see in this diagram is it has to be more than a half, doesn't it? The area that we're after has to be greater than a half. Explain to the person next to you how we know that from the diagram. Okay, so what we are after is we now want the probability that x, which is the age of a randomly selected student, is less than 26. We do this on the calculator like this. So on the calculator, get your calculator in your hand now, everybody. Remember that your numbers will be different. We press menu, probability, distributions. Always normal CDF, never normal PDF. We don't use the PDF ever. We only ever use CDF. Makes it easy. We use inverse normal as well. So we use 2 and 3, never 1.
What about a binomial distribution?
We use that if it's binomially distributed, but this isn't.
That's from last class.
That's from last class. So our lower bound here can be 0. With your lower bound and your upper bound, if you want to make it beyond the end of the normal distribution curve, make it 10 standard deviations above or below the mean, or make it something just very big or very small. Remember that almost all data is within 3 standard deviations. So by the time you get to 5 standard deviations, there's nothing left. So for instance, in this case, 3 standard deviations below the mean is going to be around about 17 years old. 0 isn't going to cause a problem. 0 or 17 as the lower bound will create exactly the same answer. Upper bound. We want the upper bound to stop at 26 this time. So we want to go from 0 up to 26. Our population mean is 24.5. Our standard deviation, this is where you do get a little stuck, is the calculator takes standard deviation. The distribution takes variance, or standard deviation squared. This will give you your answer. This is a probability, 0.726. So B. Let's do a little sketch for how B looks. We've got our mean here. So what do we want? We want 23.7. So we're looking at this value here, and we want the tail that goes above it. Have a go at finding this on your calculator now.
It's 0.626.
It's small. As it comes.
Yes, it can.
So, menu, probability, distribution, CDF. Lower bound needs to be 23.7. Upper bound can be anything nice and large.
I put infinity, is that where?
Yep. We've got 24.5, and then our standard deviation is 2.5. 0.626. So we'll go question C.
The percentage is 76.4.
670? Yeah.
76.4.
About 67.
You have to times by 100 for percentage.
Yeah, that would be 67.7%.
76.4%.
67? Oh. Look at, no, look at the mean. Look at the mean.
What percentage of students between 20 to 20? How many students are there?
Minutes happen. Bad. Times 100.
All right, so we should get these values.
But so they ask for the percentage.
So, for you, what is the answer? About 67.